of the vectors. Okay, so if you see from your appendix, okay, the first table that you have over here are referring to the transformation of the coordinates. Okay, the first table referring to the transformation of the coordinates. But you see at the back, at the fourth column of your appendix, they have put their components vectors. Okay, vectors components. So in this case, we will change the transformation for the vector from the Cartesian to cylindrical. You can use this formula. Okay, for example, if you want to find the cylindrical component vector, okay, you need to have the cylindrical in R, phi, and Z. Okay, so you will analyze based on this vector. Okay, so this one will have the value for R direction, phi direction, and Z direction. So this one will be analyzed based on the vector transformation. Okay, so if you see from the first formula, they give you, for example, ER is given by AX cos phi plus AY sin phi. So AX here are representing the magnitude that move towards the X direction. Okay, you just need to substitute the value into this equation for you to transform the vector. Okay, the same thing goes for AY. Okay, AY will be the magnitude of the Y component. Okay, that move towards the Y component. So every other things here already changed to the cylindrical. So this one don't need to change. So this one, they already have their own properties. This one already changed to the cylindrical. Okay, now let's look for the example. Okay, so if you are given the Cartesian coordinates, okay, you have your P is given by -2, 6, and 3. Okay, with your A vector is given by yx plus x plus z, y. So all these things are moving towards the Cartesian coordinates. You can see that there is a magnitude of y moving towards the x direction. So this is your AX. Okay, and you have also the magnitude of x plus z that move towards your y direction. So this is called as your AY. Okay, so this one is your AY. The whole thing here is your AY, means that magnitude that move towards your y direction. So the first questions, they want you to find the point P in the cylindrical coordinates. Okay, so what is given to you here is in the Cartesian coordinates. Okay, so they give you in terms of x, y, and z. So they want you to change it into the cylindrical coordinates. We have to change it into the r, phi, and z. So what formula that we can use? What is the r? Given the value with x. So what formula that we can use?
Square root x squared plus y squared.
Okay, so referring to your appendix. Okay, thank you. So r equivalent to x squared plus y square. So this one don't have any different things. This one is just a direct transformation from your appendix. So you just need to substitute the value for x and y into this equation to find the radius. Okay, so this one will become -2 square plus 6 square. So what do you get? Square root of
40.
40. Okay, or if you want to change in the decimal, what is the value?
6.32.
Okay, 6.32. Okay, thank you. So what about phi? What is the formula for phi?
Arctan y over x.
Y over x. Okay, so you can just substitute the value here. Y is 6 over -2. So what do you get for your phi.
Negative 71.5.
Negative 70.
1.5.
1.4.
5.6.
5.6. Okay, so in this case, if you find this axis, if you sketch this, where is your axis? Y and X. So if you have your X is -2, it's actually at the back here. -2, and then you have Y is 6. So Y is 6 over here. Okay, and then your Z is 3. So Z is 3. So let's say, for example, this one Z is 3. Okay, your point will be here. -2, 6, and 3. Okay, this one is 0, 0, 0 lah. So in this case, your phi is changing from here. But now you give me the answers to be negative 71.56. We don't want it to be like that. So can you put it into 180 minus this thing? What do you get?
$108.44.
108.44. Okay, thank you. So we will use the positive value instead of the negative value once you sketch the formula into it. Okay, so you can say that this one is a phi is 90 degrees. So this one is supposedly to be more than 90 degrees. This one depends on which quadrant that your point is located at. Okay, and what about Z? Is there any changes?
No.
No, so Z will be 3. Okay, so your point P in the cylindrical coordinates now is given by 6.32, 108.44 degree and 3. Okay. Okay, now we move to the second one. What is your vector A at P in the Cartesian coordinate system? So what is A in the Cartesian? So you just need to plug in the value only. So you have your A is given by Y. What is the value for Y?
Six.
6. Okay, so you just refer to your Cartesian. Cartesian, no need to change everything. Okay, so this one is your 6x. Okay, plus x plus z is -2 plus 3. So you get 1. So y. Okay, so for the Cartesian vector, no need to change anything. Okay, and then you have to find the vector A in the cylindrical coordinate system. Okay, so this is where you need to use the formula because you have to change this vector from the Cartesian to the cylindrical coordinates. Okay, so now let's do this one. Okay, so from your appendix, what is your, you want to change the everything, your vector to the cylindrical coordinate. So what is given by AR?
AX cos phi
AX cos phi
plus AY sin phi.
plus AY sin phi. Okay, good. Okay, here you see we solve it one by one. Okay, so what do we have here? We have our cos phi, this one already changed to cylindrical. So our objective now is we want to change every Cartesian to the cylindrical. Okay, so in this case, if you see from your given vector for AY, AX, okay, AX is the magnitude that move